Very good evening, everyone.
Good evening, sir.
Good evening, sir.
Okay, Pankti's voice I can recognize. She's always having that happy energy. But who said good evening before that? I could not recognize the male voice.
Victor Tango Mike Alpha November.
Victor Tango Mike Alpha November. Good. Good evening, Pankti. Good evening, Manan. Good evening, everybody. Welcome to the class. I hope everybody can hear me properly.
Radio 5, sir.
Yes, that's Nehal. Nice to have you, Nehal. Welcome. Varad, how do you read?
Radio 5, Victor Tango, Victor Alpha Romeo.
Good, good. Welcome to the class, Varad. We have Subhajit, Likit, Sujal, Twarita, Muhammad Azam, and Falak. Very nice to have you all. Students, a quick look at what you had done yesterday. Okay, see if you have any doubts. With respect to the things that we have discussed in class is what I'm saying if you have any doubts. Like I have seen a couple of students have sent me a few questions that are there. Maybe I think you got those questions from Oxford. So I would want you all to try. I would be giving you all practice questions from Oxford also. So wait for it. Once let everybody try, and afterwards we'll solve a few questions in the class also. So until then, what is important is you are thorough with everything being taught to you in the class. Those things are more important than what you have to do ahead, because that's how the strategy is. So your focus should be on knowing all that is being taught to you thoroughly at present. That being said, Shraddha, welcome to the class. Nukul, welcome to the class. I hope you can hear me properly.
Affirmed, sir. Victor Tango November Kilo Charlie.
Affirmed, sir. Victor Tango Sierra Hotel Romeo.
Good, good, good. So quickly take a glance at what you had done yesterday. We are going to continue, and it should not be that now we are having any confusions in solving what we are doing today. Quickly, if you have any questions, anything you need to verify, you'll do that. Okay, Victor Tango, Victor Alpha Romeo, go ahead.
Sir, I have a question on first numerical which we have solved in convergency.
What is
First
the question?
The initial GC track from A to B is 060 degrees true. What is the final GC track at B? Find out the GC track B to A. So over there we have found the convergency, but we didn't find the conversion angle, because if we want to identify the GC track from B to A, we need the conversion angle for it, right?
No, we didn't introduce conversion angle in our calculations yet. So it's not applicable in that question. Why is it not applicable in that question? It's because what your track is at B, the opposite track is reciprocal of that. Simple. That's it. So why do you need conversion angle? Basically, where you're coming from, I think you're coming from those sums I solved in your R.K. Bali textbook. Am I right? I know what you're talking about. So these sums are different. These sums are not talking about drum line. They're only talking about great circle. The conversion angle will only come in picture when you're solving the equation where you have both drum line and great circles between those 2 points. So we have not solved that. We have only solved for great circle using just one direction. Yesterday, I was just introducing, and the figures that we were using yesterday were rough figures. Today, we are going to learn the accurate figures with respect to 2D Earth and 3D Earth. So today is what we are going to learn all that. If you have drum line, only then your conversion angle will come in picture. It's actually easier, but in these textbooks, it has become a little complicated. It is actually not that complicated. Okay, earlier we used to refer that first and then Oxford and other books, but then we realized that it's unnecessarily complicated. The instructions are not clear about these topics. So there are two different things. If you are only finding great circle, then you don't need conversion angle. If a reference is given to you with respect to rhumb line, that's when you will get, what do we say?
Conversion angle.
the introduction of conversion angle. Okay, so you all need to just be very careful about it.
And if the value is greater than 180, we need to subtract it from 180, right?
That is just a way you find out your reciprocals. You add 180, and if
Okay.
the value goes more than 360, then you deduct 360, not 180. But the better way to find your reciprocal is just using your navigation computer. That is just a mathematical way. Like if I have to find out the reciprocal for 270, then what I do is I add 180 to it. And if the answer is more than 360, then whatever the answer is, definitely it's more than 360. So I subtract 360. So what I get is the reciprocal of 270. That's a technique, that's an arithmetic technique to find reciprocals. Students, keep asking your questions. Okay, anything that you have to ask, clarify. So today we are going to continue from where we left. And today I'm going to clarify certain more concepts that certain students had because they had read a few material beforehand. So just give me a minute before we go ahead and do it. I have a couple of questions to ask and you have to write the answers in the chat box. Firstly, Sankalp, welcome. I hope you're feeling better now. Subhajit, nice to see you. So good, I can see 4 students. Okay. Don't have Zaiprakash and all. We don't have Vivek Yadav also today. Okay, students. So the question is, what is the definition of convergency? Now remember, there are 2 definitions. I want you all to convert both the definitions into one sentence and put it in the chat box. What do you understand by convergency? Everything will be in one sentence. Okay, you'll put the answer in the chat box. I think you can also attach pictures in the chat box. If you're writing it in the notebook, then you can share a picture of what you have written in the notebook if you don't want to type it on your application. So I'm just confirming attendance. Okay, once more. We have Pankti, Viral will be joining late. We have Sankalp, Bharat, Manan, Nihal, Palak, Subhajit. Vivek Yadav is not there. We have Mohammad Azam, Likhit. How do you read Likhit? Likhit, you're on mute. I hope you can hear me. And we have Shatta, we don't have Sparsh, we have Nakul. We have Vivek Dhakat, right? Yes, nice to see you, Vivek. You have Twarita also, right? So I started to get answers. Good job. Quickly, very quick, students. Very nice. Convergency is the angle of inclination between 2 selected meridians at a given latitude. It is also called the change in direction of GC. Good try. At a given latitude, is it compulsory at a given latitude? Answer is correct. But can it not happen between any 2 different latitudes? Can we not measure convergency? Yeah, good. Convergency is the inclination between the 2 meridians. It is maximum at poles and minimum at the equator. Good. That is one added point. But then we have missing one more point. That is, it is the difference between the great circle tracks between the 2 meridians. So if you're measuring your convergency between 2 meridians, then your GC track, the first track and the second track, they both will have a difference of the value of convergency. And if you take any mid longitude or mid meridian in between, Then you calculate your convergency compared to the starting point and the middle meridian. And then you calculate convergency, and then you will find the change in the great circle direction. It's actually very easy. Okay. The only thing is that you have to reread it and revise it again and again. The more you read it and revise it, it becomes really easy to understand. So you don't expect yourself to just attend one length of session and be expecting yourself to be 100%. No, even after we are completing this topic today and you will be doing some assignments, after that also keep reading and revisiting. It becomes much more easier that way. So Falak, good. One thing I want to add with this answer is it is maximum at poles. If you get a trivial question wherein they say that the d long between the two meridians is 50 degrees, find out the maximum convergency at the possible latitude, and they'll give you two options. They would give you the value of convergency and give you the latitude also. The first option would be 50 degrees is your convergency and latitude is equator 0, 0. Second option would be 50 degrees and the latitude is 45 degree north. Third would be 90 degrees and the latitude is 90. And the fourth would be 50 degrees and the latitude is 90. Now, what would be your answer to this question, students? A, B, C, or D? Who can give me the answer? You raise your hand. You don't have to write it in the chat box. What is the maximum convergency between two meridians with d long 50 degrees? Okay. What do you think is the correct answer? Who can raise your hand? I'll give you a chance to speak. Quickly, students. See, all these kind of questions also we cannot teach you all these type of questions, but you have to understand this is something that you have learned. It's just that the way of the examination question is different, but the concept is the same. Only one student is giving me the answer. Subhajit, go ahead.
Sir, the maximum would be at when the meridians are 50 degrees apart and the latitude is at poles. Latitude is 90 degree because we know sine 90 is 1.
Yeah, don't, it's okay even if you don't say sine 90 is 1. It's actually true, students. In your textbooks, you will come across that convergency at poles is a factor of 1. That's it. That is one point that should not be asked in the exams because we don't directly give you questions based upon trigonometric functions. We don't do that. But yeah, it is true. Maximum is on the poles and the value is the value of d long. That's it. So if your d long is 50 degrees, the maximum convergency between those two meridians would be 50 degrees at 90 degree north latitude. So the answer is D, delta. Good job, Subhajit. Correct answer. And I like how you always try to give answers in the class. Students, try to give wrong answers also. At least try to speak up, okay? It's okay. Right or wrong doesn't matter. We all are learning. Mohammad Azam, you had something to add. Please go ahead.
Okay, I just asked, can you repeat the question? I think so.
Can I repeat the question? Can somebody give a readback on my behalf? Feedback on my behalf to Victor Tango Alpha Mike Alpha. Let's see if somebody can do that. I'll keep on reading more answers quickly. The inclination of two meridians at a specific latitude is called convergence. This convergency is actually also known as Earth convergence or Earth convergency. Okay, it's all the same thing. It is maximum at poles and minimum at equator. Convergency d long in the sine of mean line. Good. Varad, good answer. Shraddha, convergency is inclination between meridians at a given latitude. 0 at equator, maximum at poles. Good. You can add it is the difference. Varad, so you're missing 1 point. Shraddha, you're missing 1 point. Mohammad Azam, convergency is equal to the difference between the two great circle track at two meridians. Correct. What about the rest of the answer? Firstly, you will say it's the inclination between two meridians. Then you will add it's the difference between the GC track at those two meridians. And then you can add it is minimum or 0 at equator and maximum at north, 90 degree north, like that. Good job, everyone. You are there. You are giving me answers, but still I'm still waiting for that one answer that has all details in it. Inclination between two meridians at a given latitude. Manan, good answer, but there is more to this answer that you can add. Vivek Dhakar, angle of inclination between two meridians at a given latitude, and it's the difference between initial and final GC track. Good. Makes sense. These two is what I was actually looking for. You can add more points to your answer though. So convergence can be defined as the difference between gaseous times measured at two meridians. Okay. It adds to the original answer. Okay. Mohammed Azam, you have given me the formula. Good. Likit, inclination between two meridians at a given latitude and is equal to difference. Okay, so this point is confusing, Likit. That is the inclination between two meridians at a given latitude or two different latitudes and is equal to the difference between the great circle track at the two meridians. You
Sir,
cannot
I
just...
actually corrected the statement, sir.
Okay, fine, good. Okay, Mohammed Azam, try to write your answer in one only, one chat only. You cannot give me again and again, again and again. It is also equal to difference between GC direction measured at each meridian. Okay, fine, Shatta, good. You have added it. So, triangle alpha, Mike alpha, good. You have added all points, but slowly, slowly. Fine. So, was it delta? Okay, that was correct. Convergency is inclination between two meridians. Okay, equal to difference between the great circle there measured at each meridian. Zero. Good job, Shweta. It's there. All points are there in your answer diagram. And Likit, again, you have corrected it. Good. Okay, Falak. Okay. Options. This question I'm going to give you all on screen, everyone. Such questions can always come. Convergency in which the meridian converge at pole. Okay. Nukul, I need more explanation towards your answer. Panti, convergency is the inclination of the meridian at a given latitude. Yes, and it's also the great circle difference between the... It's also the difference between the GC tracks at those two meridians. Nukul, I will need more data in your answer, okay? It's not enough. Convergency is the value of convergence of the meridians at any latitude or any two latitudes. So your answer is like a very short of all the 3 points or 2 points. It's incomplete, Nicole. It is the convergence of meridians, maximum at poles, minimum at equator. Simple. And the difference between two GC tracks and those two meridians. That's it.
Good evening, sir. Sorry for the delay. I just woke up.
No, Pushkar, it's okay. Don't worry. Very good evening. I like the energy. Nice. Keep it up. We're just doing some revision. So it's okay. Don't worry.
Okay, sir.
So students, I'm going to, what do we say? I'm going to give you all this, okay? This question that I was asking. Find out max convergency between two meridians with a D long 50 degrees and mark which of the following is true. Option A, max 50 degrees at latitude 0 degrees east-west. Option B, max 50 degrees at latitude 45 degrees. Actually, for latitude, it will not be east-west, it will be north-south, students. North-south, north-south. Max 90 degrees at latitude 90 degree north-south. Delta max 90 degrees, correction, this option, max 50 degrees at latitude 90 degrees north-south. And we'll write one more option. It's okay. We'll only keep the 4 options that I've given you. This was the question. So you have to remember, at the pole, the convergency is equal to the D long And that is the maximum value of the convergency between those two meridians. Simple. At the pole, between those two meridians is what we are talking about. And why we are saying maximum? Because the same can be calculated at different latitudes. And if I calculate with the same d long at a latitude which is not North Pole, then I will not get the maximum value of the convergency. I'll get a lower value of convergency. So with the latitude, the value of convergency would change. Okay. But students, the maximum is at poles, which is equal to the d long. That is the key that we need to remember. Okay. I hope we all are thorough with this point. And now I'm going to give you one more, what do we say? Sum to solve. Okay. Please write down the question. Let's see if you remember what we had done yesterday. The question is, initial GC track from A to B is 250 degrees true. What is the great circle track from B to A, where A is equal to 40 degrees 00 minutes south, 170 degrees 00 west, and B is equal to 45 degrees 00 minutes south, 174 degrees 00 minutes east. Okay, students. What I want is a simple thing. I want the initial great circle track from B to A. What will happen when I'm coming from B to A? All right, that is the question. Take your time. I want to see your answers in the chat box. Simple. Make sure you give your answers properly. Students, I want your units to be absolutely perfect. If you're talking about a great circle track, it will be 3 digits. Don't write, you should always remember, because here you'll get confused. If you give me answers in 2 digits, I'll feel it's a latitude answer that you're giving me. It's a great circle track, it's a direction, it has to be in 3 digits. And anybody who's anywhere confused about how to do, feel free to talk, okay? Feel free to ask. Only one answer I've got yet. Vivek, I would want to cross-check your answers. .40 south and 170 west is A, and B is 45 degrees south, 174 east. Okay, correct. Question, I think question is correct. Vivek, why are you getting incorrect answer? Manan, amazing. Good job, Manan. Yes, is somebody saying something? Station calling, Mumbai control. Say again. Vivek, are you confused? What's missing?
No, sir, I am rechecking it.
Okay. Sankalp, good. You have a rounded answer. Good job. But 3 digits for your great circle directions. Imagine, not imagine, know that great circle track is directions, and directions are 3-letter digits, 3 number digits, or 3-digit values. Okay. Subhojit, something is missing in your calculation because the answer is not right. Cross check, step by step, and focus on what was taught to you yesterday. That's it, students. Varad, good job. Answer is correct. Well done. Likit, cross check. Answer is incorrect. Mohammed Azam, cross check. Answer is incorrect. Students, it's very simple. Firstly, your A to B would be a direction coinciding with 250. 25 is westerly or southwesterly. So for me, it becomes so simple that I know I'm going to travel in this direction without making anything. And all I have to do is just make one meridian here, one meridian here. That's it. This meridian that I got is 17000 west. And this meridian I've got is 174 degrees 00 east. If you're thinking, sir, why west to east is giving me an westerly direction. So students, it's the rear view of the earth. The apparent sense of direction would be reversed. So you are crossing anti-prime meridian here. That's why west to east, you are getting a westerly direction. That's it. But this track, this is what you have measured from your local meridian. That is 250 degrees true. Because your local meridian is 000 degrees true. Local lot. This is what we have learned. This is your GC track. Now, all you need to do is find out the convergency and figure out whether you're going easterly or westerly in which hemisphere. That's it. Your direction is westerly, you are in the northern hemisphere. So what will happen to your directions? Will they increase or will they decrease? By that value of convergency, you'll either increase or you'll either decrease. It is westerly because your track is 250. No matter where you are, it is westerly. And then you get your great circle track at B. And this B, you find a reciprocal to this B. You get your great circle track from B to A. That's it. Step by step. Likit and Mohammed Azam, you have to cross-check your answers. Subhajit, now you've got the correct answer. What was the mistake you were making earlier?
I wasn't viewing the Earth from the rear view.
It's a common mistake. Make sure you're aware about it. Students, see, I'll tell you all something, okay? We tend to get, threatened by something that we don't immediately understand after learning. Don't feel like that. Give yourself some time to understand a question. Don't get threatened by a question. What happens is, suddenly if you look at the question, you're like, yaar, ye west to east mera ulta kaise ho gaya? And that threat will really impact your solution. For me, I have to stick to my initial grade circle track 250. It's universal. What I've taught you the first time, this is universal no matter where you go. This is your secret weapon. This plus symbol is your secret weapon. That's it. This is 250 measured like this direction. So no matter where you are, 250 is going to be 250. The only difference is it with respect to your local meridian in that position. That's it. I've got my diagram. All I need to do is just find out this track. And I know the difference would be convergency. What happens when I'm going in which hemisphere am I in? I'm in the southern hemisphere. What happens if I'm in the southern hemisphere going westerly? Do my directions increase or do my directions decrease? Check this out. Southern hemisphere, I'm going westerly. The directions are increasing. Okay, students. What is the convergency for this? Likit, you're close to your answer, but you still are 5 degrees away from the answer. Who else has not submitted the answer? If you want to discuss something, please discuss. What's the value of convergency? Manan?
10.8 degrees.
What was D long, students? What is mean lat? Why is nobody answering?
And D long is 16.
D long is 16 degrees into sine of mean lat. What is mean lat?
42 degrees, 30 minutes.
42.5 degrees for the ease of your calculation. How do I solve it? See, I'm showing it to you all. 16. I have to make sure it is in degrees function. 16 multiplied by, I'll open a bracket, I'll put sine 42.5 bracket close 10.80. Manan, was this the same answer you gave me?
Yes, sir.
10.80 degrees, or you can convert it into 10 degrees. And how to convert 0.80 into minutes? You will do 0.80 into 60 directly. So 0.80 into 60 gives me 48. So it's actually 10 degrees, 48 minutes. For your reference, we might not need it because this is enough for calculation for us. So this is for your reference that, okay, how much will it be with respect to minutes? So your convergency is 10.8 degrees. Now, students, the choice is yours. If you want to round it off, you can round it off. Okay. Or you can keep it the way it is. Vivek Dhakat, finally you've got the correct answer. What was the mistake you were making earlier? Likit, you've got the correct answer. Good job. Are you able to figure out your mistakes? 10.8 degrees, or if you want for ease, you will take it 11 degrees. Up to you. In the exam, 10.8 can also come with respect to your answers. I'm just saying, 11 degrees also for ease of calculation. What happens in the southern hemisphere going westerly directions increase. So from 250, this would become how much? GC at B is 250 plus 11 degrees, 261 degrees. And now I want to find out B to A, that is reciprocal of B, which is, I'm going to check it out here. Reciprocal to and from 261, 81 degrees. Therefore, GC at or GC from B to A is reciprocal of 261, that is 081 degrees. Got it. So easy. Why are we confused? Are we confused in imagining where the meridians are? Are we confused into plotting? What are we confused with? Is the question you should ask and tell me so that I can help you cover up your missing point. I've given you the solution. I am telling you it is easy. You will get there. Maybe not now, maybe in a week's time, but you will get there. Be patient with yourself. Mohammad Azam, go ahead.
Sir, is there a way to find this reciprocal without using this calculus?
Yeah, there is. But in the exams, we have to use calculators. Remember, you have to carry this CX3, the real CX3, as well as the real scientific. Both you have to carry in the exams. But I will show you without that calci also to 260 plus 180. Okay, you should always do this first to find your, what do we say, reciprocal. So this calci, I'm going to use normally 261 plus 180 is equal to 441. Now, whenever you get a value more than 360 to find reciprocal, more than 360, you will minus 360 out of it is equal to, so 441 minus 360 is equal to 081 degrees. Got my reciprocal. I don't need a calculator. But this concept I have seen students really get confused with. But see, if I would have asked you to give me a reciprocal of 0980, what would you have done? Plus 180. And what do you get? 0980 plus 180, you get 270. 270 is not more than 360. So you have got your reciprocal that way. Simple. But if the answer would have been more than 360, then what you do? You subtract total 360 out of it and you get your reciprocal. So easy. Victor Tango November Kilo Charlie, go ahead.
Sir, I got 260, 43 minutes. So 43 minutes rounded to
260 degrees, 43 minutes is accurate. What we have taken is rounding off.
rounding.
Yeah. So what's the confusion?
Okay, sir.
It's okay. Be very comfortable. It's okay. It's only 43 minutes taken out of 60 minutes. You will get 17 minutes left. Simple as that. So your answer would be what? 260 and that, right? So it will be 80 and 17. 80 degrees, 17 minutes for you. It is close to 081 only. It's a rounded off value, students. A most accurate answer is 08048. That is the accurate value. If you're getting anywhere close to it, it's good. I've just shown you that you can also round it off. Simple as that. Because your answers would match your rounded off figures. Nukul, are you following?
Affirm, sir.
I have not directly given you an answer to your query. That's why I'm asking.
No, sir. Affirm. I understood.
Good. Students, when I'm indirectly trying to explain something is for me to help you recollect it by yourself. Don't think I'm deviating from answering. Okay, if you're like, no sir, मेरे को नहीं समझ आ रहा है, आप ही बताओ. So yeah, that's what I'm here to do. So don't be shy, okay? See, the only problem with good students is that they think not to bother the instructor a lot. That should not happen. It's not bothering, it's just clarifying doubts. You know, once I think Pushkar remembers that once we were preparing for navigation and we had gone to a student's place in Powai, and he was also living in his cousin's place, and we were just 2 days before the exam, and we had not covered VOR DME for him, and he was already from a different school. So I and Pushkar went to study for the whole day, but we could not learn much in that one day because after 2 days we had our exam. And no matter how much we were trying to understand one VOR DME sum, the other sum would look difficult. The human factors come into play, students. Your brain is so saturated at one point in time that anything new that you try to learn doesn't go inside. And in the end, we just had to, call it a day because it was night and we had to come back also. And that day I remember because it was unsuccessful because we could not finish all that we had planned to do in that one day. But eventually that student passed. But what I'm trying to say is I understand a few things, and the way I'm teaching you all, make sure you are 100% keeping that much is what I'm trying to say. That's why your VOR DME tracking sums we have done beforehand only, because those sums, if I teach you before the exam pressure, it gets very difficult. So now when you practice, you figure out, oh, I'm not able to still solve it. Why? Because there's always a reversal of directions. This reversal of directions will happen in two places only: your VOR DME tracks to and from, and your meridians and anti-meridians. That's it. So you have to be very comfortable with this point that, okay, if it's reversal, so what? I know what it's going to be. If this is not working, that will work. Something has to work. So that way you ensure that you get answers to all questions. Okay. Remember these points. I'll discuss these points again in future to help you before your exams. So this was Northern Hemisphere. Then my answer would be, Sujal, I'm not sure. I will have to cross check. Probably yes. If Northern Hemisphere, the answer would change definitely because the direction value might change. Okay. Mohammed Azam, quickly go ahead.
Sir, I didn't get that D long. How we got 16?
Sorry, say again.
How we got the D long 16?
Have you missed any of the sessions, Azam? For our
I'm
Earth?
attending last few sections. Sir.
Yeah. If you have missed, then I would suggest you go through that, the first, second, third lecture of Earth. Okay. Your doubt will be solved. D long is something that we have learned how to solve specifically. If you want, I'll share the link with you. Okay.
Fine, sir. Okay. Okay.
After that, you ask me any confusions here.
Negative, sir.
No, after going through the session, you discuss if you have any confusions.
Sure, sir.
Yeah. Okay. Students, sorry, I am having this sad face because I'm very low on energy today. But I'm trying to keep it happening because it's a Friday. But I'm also trying to keep it peaceful. So I hope you all are remembering to smile and all that because it really impacts. I hope when you see someone smiling and talking to you, even you feel better instead of somebody who's has in this frigid face and just here to, बस मेरे को काम करना है करके चले जाओ. We have to live this. We have to enjoy this, okay? So don't forget, and especially because it's Friday, we have to do something out of the blue to make sure that, we get into the party mood for the weekend, whether we have to party or not. So at least Manan gets the joke. He was laughing. He sent me a smiley. So I like that. Students who cannot show me your pretty faces, you can put a smiley there, right? Okay, Sujal has got it. Good. Nice. Apparently, I think it takes some time to understand my jokes, right? Sujal's been with me with quite some time. Okay, so coming back, now we are going to deal with what to do with conversion angle. And why do we need to study all this? Why are we doing all this? What is the purpose? How is it going to help me as a pilot? It's going to help you in your flight planning phases, okay? And flight planning is also part of your syllabus. And then after you plan and you get your shortest tracks to save fuel and save time so that you can do more flights, reducing the amount of fuel burn, you need great circle tracks because the shorter arc of a great circle is the shortest distance between the 2 points. So I'm going to give you all a statement. Please write it down as I'm saying quickly. Okay. And then we'll quickly go back and do for few more numericals. When flying the shortest distance between 2 points, we are actually flying a GC track. Okay, in simple words, we are actually flying or following GC track because it's the shortest distance between the 2 points. So whenever you're flying, whenever you are flying a GC track, your great circle track will keep changing over a certain time with respect to the true north by the exact amount of convergency between the 2 points. This line, please highlight or underline by the exact amount of convergency. Your great circle track, it is important to follow a great circle track because it's the shortest distance. The thing with great circle is that it will change its direction. And if you can find out convergency, you will get to know how much is the change in the direction for you to fly that great circle track and make sure you reach from departure to destination. Generally, when we are solving these sums, we only consider 2 points, but in reality, the dispatcher or the flight planner will try to make sure that they give you all prominent points in between where you'll have to make a turn. And all those prominent points would be with respect to the, what we could say, the latitude, the curvature would change, the curvature of the earth would change. So with respect to the latitude, they'll figure out as to only 2 points are to be considered or 3 points are to be considered. Generally, 3 points are enough, wherein you will have one starting point, ending point, and one mid longitude between the two. That's it. If you have those three, so you'll first find your GC track from A to B, your initial, then what will be the value of your GC track from A to the mid longitude? That is something you can find out to refine your turns. So you will know your point of turning. And students, these points are generally similar to your waypoints. If you're wondering what waypoints are, what are the purposes? So these are fixed points wherein it becomes very easy for a pilot to or a flight planner to plot everything because all these fixed points are meridians. You just need to ensure that if you're following a certain ATS route, then chances are at those meridians you might have to make right or left turns or maybe not. Simple as that. Okay. If you don't have a track, you cannot fly, students. If you don't know, everything is ready, but you don't know what route you are supposed to take, you will not take up that flight as a pilot. Even if somebody is paying you extra, some rich man or somebody in need will say, "Arey, you know how to fly a plane, right? I'll not tell anyone. Let's just take off and please transport my plane from here to there." That is illegal flight. You cannot do that. Remember, you will have a lot of power when you become a pilot, or when you at least learn to fly and get a CPL. Okay, so don't do all that if you have not filed a plan. If you want to help that person, submit a flight plan to DGC and get an approval. Simple as that. Or hire a third party. There are many third parties who do that. You don't need to learn all that. Okay, good. So now I'm going to introduce what to do with CA. About CA, that is conversion angle. It's important when we compare the GC track between 2 points with the rumline track. In bracket you will write constant direction between the same 2 points. Only then, note, conversion angle is equal to half of convergency. And another note, CA is the difference between GC track and rumline track at any given point. So we are only talking about the tracks at that one point, not the departure and destination. Only the departure, GC and RL, or only the destination, GC and RL, or the reciprocal for the same, GC and RL, all measured at any given one point. The comparison is, if I'm here right now, what is the difference between my GC and my rum line to reach my destination? That's it. That is conversion angle. Also note, value of CA at departure and arrival will be the same. All these points can really help you calculate certain questions without even having to solve them. It becomes so obvious, but only with practice too. Be gentle. Although we will be finishing how to solve, you have to keep practicing nicely. You have to keep these topics, like this is, like I have said, one of the most difficult topics to master for students. Why? Because strategy is different. And Pushkar, for you, it is going to be very beneficial, these sessions, because we have modified the way we are learning these concepts compared to what you had taken in previous sessions. So these approaches are much more simpler than the approach that we were solving. Do this, do that, find this, find that. And the whole table that we have in that textbook, you don't need that table really, because that actually makes it complicated. You solve that table at the end.
Correct.
Yeah, you actually solve that table at the end, and at the end of these things. So yeah. And students, one more thing, students, if there are any unanswered requests on WhatsApp, it's the weekend, highlight it so I get time to fulfill them. Okay, so if you have not highlighted it, if it's pending, it's my request from you all. Don't feel I'm not serious, just saying that, just bring it to my attention so that I'll have extra time and I'll do it. So now we know conversion angle, the value, how to find it. First find convergency and do half and you'll get conversion angle. You know, it's the difference between GC and rum line at any given point. Now I'm going to show you two perspectives, or two perspectives of Earth. Okay, if I show you Earth as a sphere, okay, then this is what my meridians would look like. This is my 0 degree north-south equator, and this is what my meridians are going to look like on a sphere. If this is how my meridians look like on a sphere, if I'm taking any parallel of latitude like this, okay, This is my parallel of latitude on a sphere. But on a sphere, what happens? The rum line, which is synonymous to your parallel of latitude, is a regularly curved line by the definition on the sphere. So your parallel of latitude on the sphere would look like a small arc of a small circle. This becomes your rum line. Although this is a constant direction, when you try to imagine the spherical perception of the Earth, it will be a curved line. It will be closer to the equator. And what will happen to your great circle track? Your great circle track will be closer to the poles and it would look like a straight line. But is it a straight line? No. In reality, it is a curved line. And rum line is a straight line. But when you try to sketch like this, like the earlier sketches in yesterday's class, you need to know how to make these convergence because it really helps you imagine properly. So I would suggest you always stick to making your conversion lines, whether to determine whether you're in the northern hemisphere or southern hemisphere. And then you add whatever you feel comfortable with. If you want to make your rum line as a straight line or a curved line, it will be your choice. It is our own strategy beyond what we learn from the books. But why is the difference? Because if I take a flat projection or a Mercator type of projection, Mercator is a flat projection of the Earth. The spherical Earth is looking flat on that, mostly accurate at the equators. It is something that is most widely used. If I take Mercator projection, then my meridians, okay, they would look straight. They would not look convergent like this. And on this, my rum lines or my parallels of latitude will always be like this, straight. And it will be closer to the equator. And your great circle track then would look like this. Okay. These two mean the same things. But why is the second diagram shown to you is because it helps you understand that your rum line is giving you a constant direction that is either east. If you're flying in this direction, it is east. Sorry, it is east. That is, if you're doing A to B, it is east. And if you're doing B to A, it is west, constant. So for you to understand rum line is constant, you are given this projection to solve. While if you have to assume everything as per the sphere, then you need this projection, A to B. What stands true is that the rum line track will always be closer to the equator between those 2 points, and the great circle track will always be closer to the poles. But the further definition for rum line track is it is a regularly curved line on the surface of the Earth. So that is standing true for the sphere. But the great circle direction definition cannot be proved on a sphere because it is a constantly changing track. So on a Mercator projection, we get both accurate values that rum line is constant direction and great circle changes track. But what is not correct is that the rum line is a constantly curved line. So both you do, we are making one compromise. It's not like this is perfect, the left Mercator is perfect, or the spherical perception is perfect. Both are making certain compromise. So the choice is yours. You need to be aware about the both so that you don't get confused. Because for you, everything is happening for the first time. So you are meant to get a little confused. But I want you all to thoroughly understand and tell me if you agree with these points or if you have any questions. Quickly, I'm giving you 2 minutes to do it. If you're confused, if you're not thorough, tell me. Otherwise, if you're not confused and thorough, then I will go ahead and give you certain calculations and show you how to understand. We have a couple of questions I'll answer in the meantime. Yeah, Vivek Yadav, I'm so happy to see you. Welcome to the class. I hope everything is fine. I wanted to send you a reminder by the time you joined. Yeah, we solved this question based upon the last, and now we are comparing the difference between GC and rum line between the 2 points, which is the difference is known as conversion angle. So today we are going to solve a couple of numericals that are a little advanced than what we did yesterday. Yesterday we were only talking about GC. Today we are talking about GC and rum line between those same 2 points. And this is the reference. Whatever you draw, if you are drawing this, then you will draw it like this, rum line and great circle track. And if you are drawing this, then this is how you'll make sure. This will help you a little bit. In certain situations, this will help you. In certain situations, this will help you. Up to you. It's okay. Both will come up to the same answer. All right. Now, one more thing I'm going to show you all with respect to these diagrams is the fact that how actually do I know I have convergency? Okay. So generally, if this is the spherical actual thing, and if I'm saying that my aircraft is flying from B to A at, let's say this is 30° north, both places, okay? 30° north. Then the first thing is made is a tangent, we call it, between these 2 points, like this and like this, a tangent, okay? And then the difference that I'm looking for as convergency, okay, we are not going to get into geometry. What I'm trying to show you is this tangent on Bravo, I'll make a parallel line on alpha like this to get the angular difference like this. That's it. And this angle that I have got is actually my convergency. This is that conversion angle like this. Now, if I'm telling you that my great circle track, now what happens to my great circle track? It is always measured with your local meridian as north. Remember this point. Students, you will never get this explanation anywhere, okay? Try to understand and listen. So now if I'm comparing my GC track, I'm only talking about GC track. Why am I not talking about drumline? Because if I'm going from B to A, then my flight direction is east, B to A, okay? Drumline will be constant, B to A east. I think over here I should mention 270. This is because of the arrow. I think I misspoke when I said east over here. East is B to A. B to A is east and A to B is west. Remember, and east is 0900. So my rum line is 0900. I have to ignore my rum line, students. Okay. Why? Because it's obvious. Okay. In case your latitudes are different, then I'll teach you one shortcut to find your rum line directly from your navigation computer. But look at this. With respect to your local meridian Bravo becoming your true north, what is your great circle track? It is this this angle. Clockwise is your GC track. Simple. At B, it looks like it is somewhere 60 degrees, maybe 55, maybe 65. What about your GC track? If I continue at alpha like this, if I continue my flight in 0900, what with respect to my GC track at A? Now, what is the local meridian at GC track at A? It is this meridian, this actual meridian, not the parallel one, this. Out of that, I have already got this answer, which was my initial GC track. If I say my initial GC track was 60 degrees, then this is also 60 degrees. So what is extra? Measuring clockwise from your north, what is the extra pie that I'm getting, students? It's all about having the last bite of the slice. This is extra. And what is the value of this extra thing? It's convergency. You understand how your direction changes? The direction changes with respect to your local meridian. And if right now your local meridian is not, and if you're going in that direction, your local meridian was converging that side, so you're automatically getting that extra piece of that pie, which increases your direction, and the increase is the value of convergency. Are we understanding this point? Good. Why again, students, why not take conversion angle when rum line is also there? Because we just ignored the rum line. We're not comparing. Got it? We are not comparing. That's it. That's why we are just focusing on GC, and just GC to find on your destination track. So easy. Just find out convergency with the formula that you have. Be good with the calculation. That's it. Okay, students, it might take some time. You will have this recording for revisions. I'm also there to repeat. Take your time. I'm not expecting you all to be thorough over the weekend or today itself, but you should be thorough in a couple of weeks or so if you regularly practice. Manan, go ahead.
Sir, we can also do like
in northern hemisphere, we are going from we are easterly direction, so great circle track will increase. So 6P
Exactly.
and
Yes, that is the logic. How do you think this relationship that Manan is reminding us is given to you? This relationship is given to you because this is what is happening in Earth. You see this convergency, if I'm going in this direction, my GC has to increase because of convergency only. It's convergency that is the determining factor. But what you're being taught as to DIID or what we have learned, direction, it's just a shortcut to make sure your answers are foolproof when you're cross-checking it. But now you know the actual thing also. If you don't know this, still you can solve that. You know this and you can still solve. So you know best of everything right now. Bharat, go ahead.
So how to draw conversion angle in the alternate method, whatever you have drawn in second figure?
Wait for conversion angle. I'm showing. I'm not
Okay.
started, Bharat.
Okay,
Hold.
sir.
Hold. Yes. I'll come there. Let me just address more two questions. Why is the GC track a curve on Mercator chart? And why is it a straight line on the sphere? On the sphere, students, the rhumb line is a constantly curved line, and compared to that rhumb line, your, what do we say, your great circle track is comparatively a straighter line. I'll just once more, I'm going to show you all the picture again. Okay, 1 second. All right. Good. And Bharat, we are coming to that conversion angle. Wait, okay? Be
Yes, sir.
very careful. Yeah, don't rush.
Yes, sir.
Yes. Okay. So look at this diagram, everyone. On the sphere, this is how the rhumb line looks like. Now you're looking at the Earth from the North Pole. Okay, from Moscow, you are going from Moscow to Vancouver, point A to point B. Moscow is AB. This is how rhumb line is. The rhumb line has to regularly curve so that it will cut all meridians at equal angles. If the rhumb line will not regularly curve, then it is not going to cut the meridians at equal angles. The property of rhumb line is that it cuts all meridians at equal angles. That's why we get a line of constant direction. And our great circles are not cutting all meridians at the same angle because of the convergency factor. And if the great circle would have been a curved line, then we would have got a constant direction. But because the great circle is not a constant direction, it changes its directions. It ends up becoming a straight line because it is cutting the meridians at different angles because of convergence. On a Mercator chart, we don't have that issue because on the Mercator chart, we don't have convergency shown on the chart. Okay, students. So this is the rhumb line. This is the great circle track. It is a little curved on the Earth also, but compared to the rhumb line between those 2 points, see, this is what on a sphere is. Your rhumb line is more curved and a great circle is less curved. It's not straight. But making it straight makes it easy for us to get initial track. That's why. On a sphere. And on a Mercator, because we don't have convergency, to make sure that we show, what do we say? That the rhumb line is, what do we say? Changing, it's a regularly curved line. On Mercator, rhumb line is a straight line because we don't have convergency. So we don't have to curve it to show constant direction. And then on a flat chart, how do we represent great circle to show its changing direction? Because there's no convergency, we make a curved line. If you have convergency, you don't have to make a curved line for great circle. If you don't have convergency shown or inclination between meridians is what I mean, then you have to make a curved track for your great circle. I hope this answer satisfies your question. Students, these are important points. That's why we're repeating them again and again. Whoever thinks that I already know this, my time is being wasted, just learn, okay? Just learn. Don't think like that. Hmm. Oh, Subhajit, nice. I'm getting feedback, live feedback. Good. I like interaction. Good job. Roger Pushkar, Roger Falak, Roger Subhajit. It's the first, standing true to expectations. Nobody has said that to me before. On a lighter note, many people have accused me of breaking their expectations. I'm so sorry. I don't know if you understand the joke, but yeah. So now I'm going to give you a sum and let's solve the sum quickly and see what is the whole deal about rhumb line and great circle tracks and the conversion angle. Okay. Let's solve this example, everyone. You have two meridians. Write down point number A is 0 to 0 degrees west and point number B is I'm just giving you meridian 0 to 0 degrees east. And if I have to give
Sir.
you the,
Sir,
Can
could
you
you-
please pull up the screens?
yeah, I will. Thanks for reminding. Sometimes it doesn't happen. Okay. Point number A is 0 to 0 west, the meridian, and point B is 0 to 0 east, the meridian. Okay. Can we all see the screen?
Affirmative.
Write down the latitude also. Remember, whenever you're positioning or writing your positions, the latitude is first, longitude is second. So let's give it a latitude value also. Take 30-degree north. Both. Okay, these are your 2 points. Can you quickly help me with the convergency, students? Azam, I'm going to show D long in this situation once. Please look at it. Are you there?
Yes, sir.
Azam. So whenever you're making a D long, North Pole, look at the Earth from North Pole, make
Sir.
0, 0, 0 degrees as your prime meridian and 180 degrees as your anti-prime meridian. Anything on the right is east, anything on the left is west. Now 0 to 0 west is 20 degrees from 0, 0 on the west side, measured from the North Pole like this, because it's a meridian. So it is 0 to 0 degrees west. This is A. And Bravo is 0 to 0 east, so 20 degrees. This is 20 degrees, this is 20 degrees. 0 to 0 east. It is not to scale, so don't think why that piece of pie is more and this is small. Just for reference. Now your D long needs to be calculated from A to B. So how many meridians have you crossed? That is D long. So from 20 to 0, you have crossed 20 degrees. And from 0 to 20, again 20 degrees. So here your D long is 40 degrees. And your direction is east. It's a rushed explanation, but it's something better than, not knowing anything. So I hope you have understood little, if not completely.
Yeah, sir.
Yeah, students. So D long 40 into sine 30 is equal to 40 into what is sine 30?
0.5.
Anybody wants me to demonstrate how to use scientific calculus? Let me know. 0.5.
0.5.
So your convergency is 20 degrees. Good. First step. I don't know what the question is. I don't care, students. It's all one or the other. That's it. There's nothing extra. Now we are one step ahead, basically. Now I want to plot. Okay. And let's say that plot on a straight projection or Mercator projection. So both the meridians would look straight. Actually, this question, why is it curved on this and why is it straight on that? Nobody has ever asked me that question. For me, it was something new to explain, but I really love giving that explanation because that's how it is. When you're making your notes, you can write those points down in your notes. It will be curved if there is convergency or convergent meridians. It will be straight if there are straight meridians. Simple, because direction changes because of convergency of the meridians. And similarly, on a sphere, your rumb line has to curve to make sure it cuts all the converging meridians at the same angles. If it is not a curving, then it will become a great circle only then, like that. So it's a good thing. It will keep you ahead, you know, in your future group discussions or whatever you're going to do. These points are really good. Not many people will know this. Now I'm going to plot it, students. Okay, from west to east, 0 to 0 west, 0 to 0 east. I'll make any 30-degree north over here. And this is 30-degree north over here, same. So on the flat one, will my rumb line be a curved line? No, it will going to be a straight line to show me a constant direction. So this is constant direction. My rumb line track is 0, 9, or 0 degrees east. Anybody confused why it is east? Remember, cardinal points, north, east, south, west. It is universal. It will not change. Be it your local meridian, be it your magnetic north as your reference. Okay. Now, how will my great circle look like? I'm in the northern hemisphere, so my great circle would be nearer to the, it will be nearer to the poles. That's why it is like this. On a flat chart, also like this. Now look at, with respect to my local meridian, my great circle track is lesser than my rumb line track of 90 degrees. Okay. And when I look at my destination, that is Bravo, so this is how my track is going out. You should always imagine it going out. Okay. And you can also imagine your rumb line going out like this to help you understand it better. I have just not named it. I'm naming it A and B. Now over here, there is my great circle track is shorter than my rumb line track because the angle is shorter. Over here, with reference to the north is what you have to measure. So this is where confusions happen. This is clockwise. Directions always reference north clockwise. Angular measurement. That's it. It is more than 90. So here your GC track is less than 90. Over here, your GC. Today we are doing GC. In coming weeks, we are going to do CG, mass and balance. So it's all very funny. Subhajit, you look like, sir, ये तो मुझे आता है, क्या सिखा रहे हो? No, do something so that I don't have to see that look on your face. So your GC track here is greater than 90 degrees. Why? Because it's apparently quite obvious, right? Angular measurement more, angular measurement less. That's how. And if you're wondering what is the difference between the two, by definition, conversion angle is the difference between the two. So over here, I have written convergency this. I'll write conversion angle is equal to half of convergency is equal to half of what? 40 is equal to 20. Is it correct? It is 20 convergency. Nobody is correcting me, students. So half of 20 is equal to 10 degrees. Now, what was the definition? Your definition is CA is difference between GC and RL at a point. At a point. So, at point A, if RL is 90 degrees and GC is lesser than RL, then GC is 90 minus CA, that is 90 minus 10 is equal to 080 degrees. Without doing anything, it becomes so simple for me to get my GC track to be 080 degrees over here. And at point Bravo, if RL is 09 or 0 and GC is more than RL, then by how much value? With the value of convergency angle by definition. Okay. Then by definition, GC is 90 plus CA, or run line by CA. This 90 is run line. That is 090 plus 10 degrees is equal to 100 degrees. So I've got my GC at B as 100 degrees. Bharat,
Yes, sir.
dig up your doubts if you have any.
Yes, sir.
जो भी आप तब पूछ रहे थे अब पूछोगे about your convergency angle and drum line. Sankalp, A to B 80 and B to A. Good. Students, if you can find out what is your great circle track from B to A, find it out quickly. Good job.
Sir, B to A will.
Wait,
Sir,
wait. I would want the answers in the chat box, everyone. Yeah. Who's asking? If it's a question, go ahead. If it's an answer, in the chat box. Bharat, was it you?
Yeah, sir. I'll write in chat box.
Answer, right? You're giving?
No, I just wanted to identify whether it is correct or not. That's why.
Okay, identify on the chat box. Okay. Yeah. And Bharat, don't think I'm stopping you every now and then. Keep asking questions, okay? Don't take it otherwise. You're like, sir, tumhe ko chup kara rahe hain, ye kar rahe hain, wo kar rahe hain. It's not like that, students. Find gray circle track from B to A and find GC track at A from B. I hope you have understood the question, students. Bharat, B to A, correct. Next time you have to be confident about your answer because it's correct. Good job. Well done. Vivek Dhagat, good job. Subhojit, good job. Sankalp, you were the first one to give it. Good job. Pushkar, conversion angle, good. Vivek, convergency, correct. Sankalp, everybody gave me convergency. Okay, few students. Good. How about others? And now I want, this is your answer A and this is your answer B. Find alpha, your GC track from B to A, and then find Bravo GC track at A from B. So it's your final track considering you're traveling from B to A. So if B to A you have figured out, then A would be only the difference between the initial and the final, and the difference is convergency, and you have to determine whether it's increasing or decreasing by the eastward, westward, northerly, southerly hemisphere. Subhojit, mistake. At A from B. Okay, fine. At A from B, right? At A from B. Correct. Sounds correct. Good job. Subodh is like, how is it wrong? What am I missing now? The expression. You're not missing anything. I just thought you're giving it at B. From B to A, but it is A from B. Good. Correct. Looks correct. Verify your answer, though. I have not cross-checked it. Okay, Vivek Dhakat has cross-checked it for us. Good. Good job, Vivek. Falak, good answer. How about others? Are we confused? I cannot even see if you're following or not, students. If you'll not give me answers, I'll not know. I need to know, right? If you're thorough, then I don't have to teach you anymore. If you're not thorough, I'll have to teach you again. So that's what I want to know. Yes, no, maybe I want a response from everyone.
Yes, sir.
In the chat box is fine. Pankti, convergency value is correct. Take your time, don't rush, as long as you're trying to solve. But with practice, when I say with practice, give 2 more study sessions by yourself to these topics and you'll be as fast as I feel about these points. But it only comes with revision, okay? No matter who is that person, if he or she, no matter how experienced the pilot they are or how experienced of an instructor they are, nobody is good without revisions. Trust me, students. It's not just you who has to revise. We all have to revise. No matter how many times we study or how many times we teach, we have to revise. But the more we revise, the faster it gets to understand anything. Okay, so only less than half of the class has given me answers. I think more than half of the class is like, I've logged in, mute pe rakha hai, now just hanging out with friends, I guess. Good use. Everybody must have done it, right? This thing, online bunking.
Sir, could you please scroll up?
Yeah, Nukul. So Budh is like, yes, sir, I have done this online bunking. Is this enough, Nukul?
No, sir. Sir, sorry. Scroll down.
Okay. And students, whatever whiteboard notes you all require, you will get it on request, okay? Earlier, I used to send it by default, but right now, we are short of working hands. So it's a strategy that we use. We'll give it to you for revision. But if you request, then you will get it now. So anybody who needs it, like Sujal, you needed it. I'm yet to sort out all the lectures and send it to you. But I'll do it. GC from B to A. Mohammed Azam. Compared to rhumb line and great circle track, the difference is conversion angle and not convergency. So I think you have added convergency over there. So
Yes, sir. I have added convergency.
it's okay. Conversion angle is what you have to add or subtract. Okay, fine. Okay, students, I'm waiting for more answers. Okay, Shata, I've got your answer. I just didn't read it. I'm so sorry. Great circle track from A to B. And GC track from B to A. So your GC track from B to A is correct. Your statement, it's obvious to get confused. GC track from A to B. No. GC track at A from B. When I say GC track from A to B, then that we already have, which is 080 degrees. Okay. This happens with me also when I'm writing to and from. So I have to be very conscious. Shata, are you following? It's just how we have written it down. Okay. So it's not GC track from A to B. It is GC track at A from B.
Okay, so I'll correct it.
Good. Make sure you understand. Otherwise, it will get very confusing. Anytime it can happen. Chances are. Falak, answer. Bravo. I'm checking. At A from B. No. I think you'll have to cross-check your answer. If your answer at A is 280, then at B, correction. Answer at B to A is 280, then great circle track change at A, that is your destination, would only be a difference of the convergency value. So you have to either add or subtract the convergency value from what you had at B to A. Are you following, Falak? So you have to cross-check your answer that way. Your answer for B is correct. So B to A would be, what is the value of convergency? It's 20. Your great circle track at B, students look at the diagram, everyone. I'm going to show you all the final calculation. My GC track at B from B to A at B is this. Reciprocal to my 100. So my reciprocal of 100 is 100 plus 180 is equal to 280 degrees. I got it. Okay. Now I want to find out at B from A. This is what I want to find out. This value. And this value is actually measured from the local meridian up to this much, like this. How much is the change? The change between two GC tracks is the value of the convergency. Simple. What is convergency? Convergency is 20 degrees. So what will be the change in direction? It will either increase or decrease by 20 degrees only. How to know whether it's increasing or decreasing? We follow this. If you're in the northern hemisphere going westerly, your directions are going to decrease. See this part. Upper is the northern hemisphere, NH. The lower is southern hemisphere. So this rule is very important to make it easy for us. So I know my direction is going to decrease by how much value? By the value of convergency. So what was my convergency value? 20. And decrease from what? The initial GC direction. So GC at A from B is equal to 280 minus the convergency is equal to 280 minus 20 is equal to 260. So this is the correct answer. Students, kindly acknowledge. Are you thorough with this?
Affirm, sir.
Affirm, sir.
Affirm, sir.
Affirm.
Affirm, sir. Affirm, sir.
Good, good, good. Okay, we're going to take a quick 10-minute breather. Okay. So come back at 16:40 or 41. We'll try to finish the next things by 7:15 or 7:20 max. I have to go for another session at 7:30, but we will have that much of time before that. So we are going to do one more sum and then we are going to do departure. It's easy. Okay, students. So come back in 10 minutes, everyone. 1841. It's become 1842. I'll see you all in 10 minutes, everyone. Welcome back, everyone. I hope everyone is back. Please let me know in the chat box.
Reform.
I have one question. Sankalp, I think, I hope you're there. Students, just let me know, okay, if you're back.
Affirm, sir.
In Boeing 737, we have course button besides AS, select button. What is this AS? What are you referring to?
Airspeed, sir.
Airspeed, okay. Airspeed select button. What's the use of that course button when we already have heading selector? If you can send me a picture about what exactly, which part of cockpit you mean, then I would be able to give you the accurate answer. Do you mean to say that horizontal bar above the cockpit? Like the cockpit
Yes, sir.
displays,
Yes,
it's a little
Yes.
outside of the cockpit. If
So
you're talking
besides the
about,
auto throttle selector, sir, it is the course button.
The MCP. On the MCP, right?
what's the full form for MCP, Pushkar?
Mode control panel.
Actually, students, sorry, Sankal, I think what you're talking about is the panel to control your autopilots, basically.
Yes, sir. Autopilot panel, sir.
Yeah,
Control.
yeah. So that is designed in such a way that you can easily just adjust or feed in data to be followed by your autopilot in real time. So just send me a picture of that and I will give you a brief description about it. Okay. So we have course button aside heading. So you have to understand your heading and course will not always be the same. You see, because of the wind effect, course and heading could also vary. So somewhere, you should think about these connections possibly. Okay, we'll come to it. Do share with me exactly. I want to see which button you're talking. I think I've got the right button, but I would want to know. Okay. Now, students, I'm giving you one more answer to solve. I hope you have written all the important points about conversion angle properly. That conversion angle is same at A and B. It is going to be same. Remember, all those points are given here. Value of CA departure and arrival will be the same. Okay. I'm giving you one equation and then I'm going to show departure questions quickly. We have already solved departure questions, so it's okay. Fine.
Sir, I've sent you on WhatsApp.
I will check. Okay. Now, what do we know about departure? Yesterday, almost everybody gave me the correct answer. Departure is the rhumb line distance between any 2 points on a given latitude. This is departure. This is departure. Both are departure. Okay. The value of departure in terms of length is highest on equator. Okay. Where 1 degree is equal to 60 nautical miles or 1 minute is equal to 1 nautical mile. And this 1 nautical mile, where 1 nautical mile is equal to 6080 feet. This also you add, okay? Now what happens is this value over 30 degree north, 1 degree is for you, is it going to be 60 nautical miles? No. Why? Because the length is reduced. And so in order to find the length of this particular distance, I need to come up with a new formula. And the formula is your departure formula. Departure is equal to d long in minutes into cos of latitude. Is it correct, students?
Yes, sir. Yes, sir.
And the value is in nautical miles only. This is what departure is all about. If it would have been on the equator, students, then you would have done the same thing. Let's say I'm taking same two values like earlier, 020 west and 020 east. So the d long is 40 degrees, 40 degrees into 60 to get in minutes. This is point number 1 to remember. You need to convert your D-long into minutes only for your departure. I'll use my scientific calci to do it. Anybody who wants to see how to use it, let me know and I'll share that on screen. So I get 2400 minutes into cos of latitude. What is cos lat? Cos 30. That is 30 in the question. So cos 30 is equal to, students, you also solve and tell me if my answer is correct or not, okay? So cos 30 is equal to 0.86. Is equal to 2400. What I get is 2078.46 nautical miles. So if you want, you can round it off to 2070. Correction. 2078, 2079, 2080. Any is the answer over here. Okay. Yeah. And let's say that I want the same departure between on the equator. Okay. So departure at, so this was departure at 30 degree north. Now, same points, I want departure at 0 degrees north south. So my D long is same, 2400 minutes into sine, correction, cos of 0. Cos 0 is equal to 1 into cos 0, because my latitude is 0 degrees. Equator is equal to 2400 into 1. Cos 0 is 1 is equal to 2400 nautical miles. Note, departure is max at equator and least at poles. Now this here itself is a proof. Can you quickly give me the departure at 90 degree north?
0.
Find departure at 90 degree north. I want everybody to cross-check the answer that Pushkar has given by solving. And Pushkar, you also cross-check by solving.
Side 0. Cos 90 is 0.
Did we take D long? Same. D long is equal to 2400 minutes. Cos 90 is equal to, cos 90 is equal to 0. So 2400 into 0 will give you 0. Like that. 0 nautical miles. Least. It's 1 point. Imagine if you reach North Pole, you can say, oh, I am at all meridians at the same time. And you will be true saying that. So many people have trekked to the true North Pole. You can also do that in future if you like adventure. Got it, students? Departure is easy, but it will be confusing when you get complicated questions. Do we have any questions? We know what is departure. Okay, solve this example. Quickly, students, as fast as you can. We can do it together. Otherwise, you'll have to do it on your own. The position A is 60 degrees, 00 minutes north, 005 degrees, 22 minutes west. Position Bravo is not known. Question is, you fly east for 165 kilometers. What from A? You fly east for 165 kilometers from A. What is your new position? Okay, students, A to B flying east. If I have to, plot it, I'll say this is A, 005 degrees, 22 minutes west, the meridian, and I'm at 60 degree north. Probably I'll say this is 60 degree north. I'm going east. It means, students, you're following a line of constant direction. That is your hint. If you're confused later on in the examination, you're confused as to, oh, I don't know if I should solve it using two meridians, GC, rum line, or I should solve it using departure formula. This is the key. Direction is directly given to you. East. It means you're going straight. How far are you going? 165 kilometers. What is our length of unit to determine, what do we say? Your departure? It is nautical miles. How do we convert it? We take our navigation computer. Okay. There is a unit converter function in that. We choose that function and change our length from kilometers to nautical miles. Then those nautical miles will convert into degrees minutes, and that degrees minutes will add as a d long to our point A, and then we will get our point B. Nukul, are you following? You look bored.
Yes, sir. It's a little bit fast for me right now.
Okay. Where did you give up in this question?
So earlier, when
Tell me. Try to focus a little bit. Departure, are you thorough? How we are doing departure? Departure is rum line. It will have a constant direction. It's just that depending upon which latitude you are, departure will always be calculated at a common latitude between 2 points. Only the meridian will change. So if that is the case, then the problem is what happens on lower latitudes or equators, the length between any two meridians is very high or maximum, constant direction. But the same d long at a higher latitude, the distance decreases because of convergence. Okay. So we don't have to account for all that. I just need to know what is my departure distance at 30 degree north. Distance, I want to, when I say departure distance, I mean the distance along this rum line. That's it. How to find it out? The formula is d long converted into minutes. So d long, to find in degrees. The same you multiply by 60 to get into minutes, because 1 degree is 60 minutes. And multiply by cos of the latitude that you are in. You don't have to find mean latitude here because you are already on a common latitude or the same latitude. So this is the formula. D long, whatever you get 40 in minutes is 40 into 60. That's just converting it into minutes. And then that we multiply by cos latitude. Cos 30 degrees gave me 0.86. And 40 degrees into minutes give me 2,400 minutes, like that. Why are we taking this? Because the comparison is between 1 minute is 1 nautical mile on equator. So how much is it at 30 degrees? This is the formula to find it out in layman's terms. That is departure at 30 degrees. In the exam, in the equation, the question that we have been given this departure distance. So the distance is given to us. We just need to find out the destination meridian. The destination latitude is going to be the same, whatever it is, 60 degree north, because it's departure. All we need to find out is a meridian, and we'll get it if we find d long. And d long is there as a part in the formula. So what is the formula? The formula is departure is equal to d long into cos of latitude. Your departure is given to you. This is departure, but this is in kilometers. We need to find it in nautical miles. So how do we convert it? We take our conversion on our navigation computer. I hope everybody can see the screen. We press unit conversion. We get into distance. We change the unit to what the unit we want. You can press the converter unit button, which is the third button on the fourth row behind the small cursor. It came to kilometer, I guess. Yeah. I'll put 165 and then I will enter it so that I get a green check. And then I'm going to press the unit converter to get it in nautical miles, 89.9, or I'll take it as 89 nautical miles. So my D long is, I don't know my D long. I know my departure, which is 89 nautical miles into cos lat. What is my latitude? 60 degrees. What is cos lat again? I'll use my scientific calci. Cos 60 is equal to 0.5, like this. So this is my formula, 89. Now my D long I have to find out. This multiplication over there, it goes, it becomes division. So 89 upon 0.5 is equal to my D long. And then when I solve this, 89 divided by 0.5 is equal to 178. Now this 178 is minutes. Okay. You have to convert it into degrees. So you will divide it by 60. Note
2.96.
Convert minutes in degrees, divide minutes by 60 is equal to 178 divided by 60 is equal to 2 degrees or 2.96 degrees, like this. If I have to convert it into degrees, minutes and seconds, then 2 degrees and 0.96 into 60. I discussed this again, but like this. There's a shortcut to do it in your scientific calculus also, but I like this method faster. Is equal to 57 minutes, and you are further getting 0.6. So I'm just converting 0.6 into 60 is equal to 36 seconds. This is your actual D long. If you want, you will round it off to 2 degrees, 58 minutes, like this. Now you have traveled eastwards. Here you have traveled how many nautical miles? Departure was converted 89 nautical miles is what you have traveled. This position, what is this position? You are getting a D long of 2 degrees, 58 minutes, or you can actually round it off to students 3 degrees also, okay? Whatever helps you, because 58 minutes is close to 3 degrees. First, you can learn how to do rounding of values, and then you can, fine tune your answers with accurate answers also. Even if I take 3 degrees to make it easy, what have I done? From 00522 west, I'm going 3 degrees east. So 00422 will be 1 degree. Then 00322 will be 2 degrees. And 00222 will be 3 degrees. Because I'm going eastward. So my longitudes, if I have to plot North Pole 000, if let's say this is 005, then 3 degrees towards the east will give me 002, like this. So at 00522, I'm taking 00222. So my new meridian would be the D long of 3 degrees would give me 002 degrees and 22 minutes as a rough figure. I have to give this as my answer. What is your final position? My final position is 002, 22 degrees west. It is incomplete. The correct answer would be final position 60 degrees north, because of departure latitude is same, and 002 degrees 22 minutes west. Okay. Subhojit, checking your answers, everyone. Okay, only 4 students have sent. Vivek Dhakar, good. Sankal, degrees you put star. Okay, fine, no problem. Correct answer. Even if you don't put degree and any symbol, it's understood because most of your questions will come across only 5 digits. So the first 3 are degrees and the next 2 are minutes, like that. That's why I say 3 digits, 2 digits, you have to compare. Subhajit, correct. Subhajit, not something is missing in your answer.
Sir, I have
It's
sent a correction answer.
Okay, fine. I will check. Correct. This is good. Good job. Fine. Sujal, something is missing. You made the same mistake that Subhojit had made. You both have given me the same incorrect answer. So try to rework it. Okay. How about others? Why are others not giving me answers? I hope there's a legit reason to that, students. Maybe you're busy or occupied doing something else.
Sir, could you scroll up?
Yeah, wait. Be very careful. You will get there. I'm not expecting you all to get there, but I'm expecting you all to tell me whether you're getting there or not. Okay.
A little down, sir, near division.
Mohammed Azam, please request it on WhatsApp so that I remember to send it on WhatsApp. Likhit, good job.
Roger, sir.
Good. Okay, students, it is easy. It's just that there will be complications to these equations. I'm going to give you those complicated questions also. I'm not sure what others are doing, students. Please update. The chat box is private. It's no more for everyone. Whatever you send will only come to me. Just acknowledge in some of the other ways, students.
Sir, we divide 89 by sine 60, right?
What? What are you saying?
89.
Sine
89.
Sine 60.
It's
Yeah.
cos 60.
Yeah. Cos. The formula is cos.
Oh, yeah. I've done sine 60.
That happens initially. Who was the nice person to clarify directly? No, it's cos. It's not sine. Who was that?
So it was me, Victor Tango, Victor Alpha.
Nice, Vivek Yadav. Good job. Manan and Pankti, I've got your acknowledgement. Thank you so much. Okay, fine. I'm giving one more question in the meantime. Okay, fine. Quickly solve, okay? Quickly. Try to be as fast as you can. And I'm sorry, students, if I'm going a little fast. I'm so sorry. I don't like doing this. But anyway, we have to increase our speed of learning. So sometimes you can, if you're not understanding, tell me to speak slower, okay? So yeah, if D long is 44 degrees 11 minutes and departure is 2000 nautical miles, find out your latitude. Okay, so again, formula, departure is equal to D long in minutes into cos lat. You're required to find cos lat. D long is given to you. You need to just convert into minutes. departure is given to you. So departure is 2000 nautical miles is equal to d long in minutes. How to do in minutes? Keep 11 minutes aside, do 44 into 60. Two 640 plus 11 is equal to 2651. Students, if I'm solving and you're not able to solve, please let me know, okay? You should not be like, yaar, sir, to maza mein kar rahe hain, mujhe to samajh hi nahi aaya. In English, you should not think like, oh, sir is doing, I don't understand. I don't like such classes, to be honest, where the instructor is just doing and his instructor is not taking care of whether the student is following or not. So, yeah, I'm not trying to do that, okay? 2651 is your D long into cos lat. You have to find out lat into cos lat. So here it will become 2000 divided by 2651 is equal to cos lat. Okay. So 2000 divided by 2651 is equal to 0.754 is equal to cos lat. If you want to find latitude, you have to take your cos over there, and when you take it, it becomes cos inverse, like this. How to do the cos inverse in your calci? There is a shift button. You press the shift button once, and then you press cos. You should be able to see cos 1 like this. And then you add cos minus 1, that is cos inverse, and then you add 0.754. You get is equal to 41.06 degrees. I've got my latitude is equal to 41 degrees and minutes. 0.06
4 minutes.
60.
3.6, but we have rounded out to 4.
I'm checking it, Pushkar.
Yes, sir.
60 is equal to 41 degrees, 3 minutes. And again, 0.6 seconds into 60 I can do. So 0.6 into 60. 0.6 into 60 will do 3 minutes. 41 degrees, 03 minutes, 36 seconds is my latitude. Or you can simply round it off to 41 degrees. North, of course. It's not mentioned, right? North or south. So what do you think? Will it be north? Will it be south? It would be both places the same thing. So Vujit, following?
Yes, sir.
Oh my God, so many correct answers. Amazing job, students. Everybody is giving correct answer.
So what was the answer of cos 0.754?
That is not cos 0.754.
Cos.
That is cos inverse.
Yes, sir, cos inverse.
Yeah, I'll check again. Shift cos inverse 0.754.
41.0.
41.06.
Yeah.
See this. Sorry, I didn't write it. Cos inverse 0.754, like this. I'll write this step. Sorry, I missed writing this step. I made it to direct. So it will be cos inverse 0.754 is equal to latitude, like this. This is the step. Therefore, and then I do cos inverse, I get this. Therefore, cos inverse 0.754, it gives me 41.06. And when I convert it, your answers might be into decimal degrees only, students. High possibility. You might not have to convert it into minutes and seconds. Although Subhajit, your minutes are little way off from the answer. Maybe you have taken some accurate values.
Sir, I have taken 0.754 as 0.75, only 2 digits after decimal.
Okay, see on the surface of the earth, small values, the third value of the fraction can result into at least how much? 20 minutes difference. And that 20 minutes on an equator would be 20 nautical miles. Yeah. So that's why for you it is easy. Everything is very easy for you in CPL studies because we cannot just expect you to do aeronautical type of mathematical calculations. That's what it is for you. So everything is very easy for you compared to the level of difficulty it could come. It could happen. Okay, students, I'm going to show you all a couple of more formulas. Make a note of it. There is another interesting concept. This example is something that is there in your Indian textbooks also quite more. Aircraft leaves A at 40 degrees south and flies as per the following run lines. Okay. A to B, the aircraft is flying 180 degrees true. Now, don't be scared if 180 degrees true is run line, thinking, sir, run line is only 0980 and 270. No. Flying along a meridian also gives you a constant direction, either north or south, and 180 is south. So when you're flying A to B, you're flying a run line track of 180 and you're traveling 240 nautical miles. Then you're traveling B to C at 270 degrees true. And again, you're crossing 240 nautical miles. And then C to D, you are flying a constant direction of 000 true. And again, you are flying for 240 nautical miles. Find run line, bearing, and distance. Bearing is your direction and distance of D from A. Looks difficult, but the starting point is something that we need to focus. A to B 180. What does it mean? It means A is here. This is B. This is 180. This you have traveled 240 nautical miles. Why? Because it's a meridian and cardinal points will tell you this is north, this is south, this is east, this is west. South is 180. You're going south on a particular meridian. You can mark A here and you can mark B here like this. The distance is 240 nautical miles. Because you are in the southern hemisphere, if you want, you can make it more accurate. But first you make this rough. So A to B, you're going southbound 180 to 40. From B to Z, you are going west. So what is west? This is west, students. Cardinal points 270. So B to C, this is C. How much? Again 240 nautical miles. This was 180 true. This is 270 degrees true, your bearing or your direction. B to C. Then C to D is north. So apparently from C, you are going up and this point becomes D. Your track is 000 true and your distance traveled again is 240 nautical miles. So initially this direction, then this direction, then this direction. Okay. DC to D is given. Now they are telling us find out the run line bearing and distance of D from A. So they are saying the same thing now. D from A, what is the run line direction and what is the distance? That's it. So obviously the run line track or the run line bearing is, what is it? Is it not obvious looking at it? It looks like it is going westerly and westerly is 270. So half of the answer I have got. My run line track at D from A is 270. Got. I want to find my distance. Distance is departure. D long into cos lat. Are you following, students, what's happening? I might be a little too fast, students. Don't worry, you will get the offline session to revise. Okay. It's just
The
that
recording
you
has
have,
been stopped.
it's okay. You will have it on YouTube. It's okay. The memory is full in my hard drive. Cannot do anything in the live class. But I think the session you can record. I'm not sure if you guys are recording, but you will get it on YouTube. Don't worry. So D long into cos lat, students, your track you have got 270. You just need to find out the departure. And if you remember, your starting point was 40 degrees south. So delta is also at 40 degrees south. Anyway, you have covered the same distance, 240, 240 opposite. So you just use the formula. Your departure is something that you have to find out. Your D long is something that you need to calculate. And your cos would be for 40. Only thing to find out your D lat, your D long in minutes is tricky over here. And if you are, thinking about it logically, then I think you will be able to find it out. What is your D long?
So can you scroll a bit up, please?
Yeah, 1 second. Okay, this good?
You have made a mention of any latitude, longitudes earlier on the question, same question I'm asking.
Negative. No meridian is mentioned. So students, what you can come to recollect is, because this is your great circle and this is your great circle. Remember, all your meridians are great circle. So you can convert 240 into degrees by 240 nautical miles. Divide by 60. What are you getting? You are getting 4 degrees. So it means you have a D lat of 4. And because you're going southbound, the new latitude at B would become 44 degree south. This is the confusing part that I was talking about. And at 44 degrees south, you were traveling, and here this is also 44 degrees south. You have your departure, you have your D lat, or you have your lat. So you can, using this, you can find out your D long, and the same D long you can use for 40 degrees to find out your answer. Because the D long will not change. The difference in longitude will not change. The difference in length is something that is going to change. So this was the missing key. I can see everybody is saturated, like, sir, bus ho gaya. Now we don't care, we learn or not. But it's okay. Maybe another half an hour is something that we'll be giving to this topic on a Monday, where when I'm giving you some questions to solve as an assignment, you will try your best to solve all those sums and send me your assignments in via email. Okay. And as much as you can finish. Whoever is busy with other things, even if you do 2 sums and send and say, sir, others I will cover up, it will mean a lot. And whoever is not busy with anything else, I'm expecting you all to cover as much as you can. Okay, so that Monday, when we are starting our next session, navigation, we will just finish this where we are leaving once. It will be a good refresher. And I'll introduce one more formula to solve the same method. Okay, and then we'll be good to go to the next topic of learning air navigation. Okay, so be on the lookout. I might take some time before the end of night to send you the material. Until then, you can chill and relax. Yeah, Subhajit, go ahead.
Sir, I've sent the answer. Can you please check?
Same
Yeah.
here, sir.
Huh. Huh. So Rumline bearing, to already we have the answer as 270. Okay, everyone who's not given Rumline bearing is 270. Remember, you're going westerly direction. A to B, A to D is going. So 090 is incorrect. And your departure is correct. Likhit, departure is a little wrong. It cannot be the same at both the latitudes. So it will be a little higher compared to 44 because 44 will be smaller. So what 240 was there and what you are at 40 degrees, that logic, your answer will be more. Vivek, correct. Subhajit, correct. Vivek Dharkar, D long. How did you get D long? Okay, fine. D long as a value, fine. Makes sense. Good. Sankalp, correct. B to
Sir,
C.
one question. Can we just assume the meridian to be prime meridian? Can we do that or we cannot?
It's not necessary actually. You don't need the meridian, but any meridian will give you a great circle value only. So if you want to assume, you can assume and work around with it. It will help you make more better assumptions. So you can try and do that. You'll get a reference for D long. You can find out your new position only, but that would be with reference to your assumption. So
Okay.
you do it or you don't do it, it won't matter. If you're missing that, oh, I don't have a meridian, then somewhere we are not following the steps that I'm asking you all to follow in this. Start with A and follow the initial track. If it is 180 or 000, it is the meridian you are following. It's a great circle. Then whether it's a right or left, it's a rum line. Then again, it's north or south, it's great circle, like that.
Correct.
Okay, students, I'm sorry, but a lot has to be done. I'm going. You all take care. I'm not sure, but I'm hoping everybody is following. If you are not following, drop me a message, okay, over WhatsApp after the session. Monday, we will have a session. I'll confirm the schedule, mostly 5 o'clock. Exact schedule will be shared over email, and the assignment and everything will be given to you. Don't panic. Go with your own speed and don't compare with anyone else. Okay. I'm going to see you all on Monday. Have a good weekend. And I'm just to call or text away and highlight all your doubts that are pending to answer. Okay, students, I'm taking your leave. Enjoy.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.